I'm Catherine Moriwaki, Associate Professor of Media Design at Parsons School of Design.
Hi, I'm Xingxing. I am the Assistant Professor of Interaction and Media Design at Parsons.
This week's theme focuses on illusion as tactics.
We're going to introduce a wide variety of examples from different cultural perspectives and different tactics on how different forms of illusion can serve as a form of defensive mechanism.
But first, before we get on to the rest of the lecture, we're going to talk a little bit about loops, specifically programming loops. Now, in everyday life, we encounter loops. This right here is the popular cereal Fruit Loops. On the other hand, there are many instances in everyday life that loop. For example, our daily routines, maybe our schedules, work schedules, life schedules, things that happen over and over again and are repeated throughout the day. But in programming, when we're talking about looping, we mean something fairly specific, actually. In programming, a loop is basically a sequence of things that happen until a certain condition is met. And here we have an example of cross-stitching. And what's happening here is a pattern for basically how to create a little watermelon icon. And in this case, you have a certain kind of stitch. It's a cross stitch. You do it over and over and over again until a certain condition is met, either a number of stitches across or a series of stitches in a particular pattern. And once those number of stitches have been achieved, you stop and you'd go on to the rest of the pattern. This functions really similarly in terms of how programming loops operate. And so with looping in sort of everyday life, or looping in examples that you'll find out in the world, this right here is an image from the Gee's Bend quilts. And Gee's Bend is actually in the South. It's a community comprised of American Black women who have a quilting tradition that runs parallel to a lot of abstract modern art. And in quilting, it's a looping process, that of going ahead and taking a square of fabric, fashioning it into a section of quilt, and then repeating that process over and over again. What's really interesting about the Gee's Bend quilts is that not only are they very arresting and original sort of visual pieces of artwork, they're also works of art that are part of a cycle of reuse and repurposing. The Gee's Bend quilts were made out of discarded clothing and repurposed clothing, which was then, after, breaking down enough to no longer be suitable for clothing and regular wear, was repurposed and refashioned into these quilts. And we also have a diagram that communicates the difference in economies, either linear economies that result in waste or pollution, waste product that languishes in landfills or is otherwise polluting, and a circular economy wherein which everything that is created is able to be repurposed and remade and recycled, so that we find that the amount of waste in a product cycle is actually greatly diminished.
Next, we are going to look at one layer deeper, the relationship between textile and data, as well as textile and language, and how it is possible to begin to think about communication through the creation of textiles.
This is an example of the quipu, which is a system that was employed by the Incas to record information. And so in this case, knotted cords are used to record countable information. Colors, the knots, the distance between the knots, and all of these sort of material characteristics of how this particular configuration of knots is established is used to basically identify the characteristics or even the type of object that's being recorded. So this recording system was really important to the Inca Empire. It was sort of based on a decimal system. And so each of the knots, the system of knots placed and positioned along the length of cords represents single units of tens or of thousands of units. It's a very fascinating example of how data was actually recorded in material form pre-computation, but at the same time actually exhibits a lot of computational characteristics in terms of how information is recorded and the underlying logic around which that information is organized. And this is an example of the textile computer. This is by Irene Posh and Ebru Kurbach. This is actually a functioning computer entirely embroidered with gold threading, using electromagnets to represent the bits of data that a computer records. And so functionally speaking, this tapestry or embroidered length of textile functions in the same way that a computer does. The only difference being that in terms of scale, this form is large enough and physically manifest sort of in a scale for us to be able to see the literal electromagnets flipping on bits from zero to one. And at the same time also harkens back to a period in computing in which literal electromagnets were used in computation, a kind of pre-semiconductor era version of computation. And so it's a fascinating project that suggests to us an alternative history of computation and what might have happened had the inspiration for computing via textiles also might have become the vehicle through which then computation was realized and fabricated. And the early ancestor of computing, this is the Jacquard loom by Joseph Marie Jacquard in 1801. The Jacquard loom has the distinction of inspiring Charles Babbage to build, or inspiring Charles Babbage with regards to the possibilities of computation and the possibilities of computers and computing. He was greatly inspired by the Jacquard loom. And the way the Jacquard loom works is, at least originally, used to be operated by small children, apprentices to a master weaver, say, for example. So the Jacquard loom was originally manually controlled. What ended up happening with the Jacquard loom, and especially Joseph Marie Jacquard's version of this Jacquard loom, is that it was a loom that was driven instead not by manual human intervention, but automatically through a punch card system. And so it's this punch card system, the fact that instructions could be encoded onto pieces of paper, run through the machine, and then executed by the machine, that inspired the likes of Charles Babbage, in terms of the possibilities of computing.
And there are many different artists, designers, technologists, programmers who are really fascinated by this relationship between weaving, textile, as well as programming. So Ari Lee, that you see here, is one of those people who have really deeply explored the relationship between a Jacquard loom, as well as how programming functions. So here you see, this is the residency that she did at the Women's Center for Creative Work in Los Angeles, where she created a series of workshops as well as artwork that uses textile, uses weaving as a technique to represent data. So what you're seeing on the left here, this piece she's calling Disrupting the Industry. It essentially is a visual dataization showing the number of computer science graduates that has, you know, sort of taken place. People have enrolled in computer science program in the last 44 years actually. So what you're seeing here is a peak in 1970s where there were enormous amount of women who were enrolled in computer science program, and compared to now, which is the bottom of that piece of textile, 2020, the gender sort of inequality between women and men and how welcome they feel within the computer science discipline has actually hugely increased. And the piece on the right, she titled Ada, is a direct reference to Ada Lovelace. And what you're seeing, the little dots and lines inside that piece are essentially representing a encoded message written down by Ada Lovelace. The message is, the analytical engine weaves algebraic patterns just as the Jacquard loom weaves flowers and leaves. So in a way, it's a homage to Ada Lovelace and a kind of play on encoding messages within the using the technology that Ada Lovelace was herself inspired by.
This is a work by Guillermo Bert called Encoding Textiles. And this is a project that consists of 10 woven textiles, each that depict QR codes. So the textiles themselves are scannable. And when a viewer scans the QR code depicted in the textile, what happens is they're sent to a website that plays video and audio, basically 20 videos and audio stories that draw from interviews with indigenous immigrants, predominantly in Los Angeles. The project doesn't have a date stamp attached to it, but from what we can gather, it appears to have started in 2012, and in various different forms is sort of ongoing. But a lot of what Guillermo Bert did is fascinating because of the way in which he worked with indigenous weavers, master weavers from, say, areas within Chile and other parts of Latin America, and also draws attention to the fact of the harsh conditions and challenges that migrants face from that region here in the United States.
Here is another example created by a couple of different groups of people called the Cryptographer, and essentially using a very similar idea where different kind of patterns became a encoding of English alphabets. And essentially you can see that they draw the pattern, they design the pattern on inside the computer on a screen, and essentially attached a paintbrush, a bleach brush actually, onto the plotter and drew the pattern out onto the textile. And the scarf, when worn, is obviously you're not able to decipher the messages, but when it's revealed, you are able to go through a decoding process to see what the message says. And tracing even more backward, we can see and find a lot of examples of a practice that involves embedding messages, and in this case specifically secret messages, inside of textile during the wartime. So a couple of different actually spies and resistance fighters during World War I and World War II, such as Felice Latour Doyle, where one of the earlier spies who were named to have used this practice to deliver messages using knitting as a kind of medium. So similar to programming, knitting also work in a binary way. So when you're knitting, you can either go under a thread or over a thread, and that actually map really well onto the way the Morse code worked. So actually right after the invention of Morse code, there were a lot of fascination on the correlation between Morse code and knitting, and this kind of practices essentially got turned into a way to embed messages.
And there are many examples within textiles and knitting, cross stitch, that relate to mathematical as well as programmatic concepts. This right here is a project called the Wearable Turing Machine. And what it is really is just a proposal to simulate a Turing machine using knitting as the output. So a Turing machine is a mathematical model of computation, right? So it's an abstract machine working with characters on an endless tape. And in this case, the endless tape is actually a line of, or shall we say, an endless tape of yarn knitted into characters. Therefore, basically creating this sort of endless record of what the machine is computing. So the idea would be, it's basically instructions for how you go ahead and simulate this machine, but then again using knitting yarn as the sort of tape. And right here, we thought we would be remiss if we did not mention activism in the age of COVID, and how basically researchers are looking to close the loop, right? This is an example of a research project that looks at methods of dissent and collective action under COVID. So it's a crowdsourced list of the different ways in which people are engaging in activism and advocacy during the pandemic. Rather than, in many cases, not everybody can go out into the streets and protest. And so if that isn't an option for a person, what is it that they can do that is still socially distant, that operates at the kind of remote scale that many people are working at right now, but at the same time allows people to engage in meaningful, community-driven engagement with important issues that are happening right now.
So the last part of the lecture, which relates to the assignment, is thinking deeply about encoding and decoding. So this really kind of circled back to our week 1 lecture on what is code and why code, right? And thinking about encoding and decoding is, in this context, is essentially we are really trying to dive into thinking about patterns of markers, system of markers, and how we can use something called steganography as a tactic to embed messages. Here, this is a example of encoding and decoding. And when thinking about encoding and decoding, it's always useful to think about, who is the code for and in what context, and when is it concealed from others? Is it intentional, or is it helpful to sort of bring transparency into play? So here on the left, you see this is the Braille language that usually has to be experienced through touching and through it's a tactile sort of printed language, where on the right what you see is a typeface that someone has designed named Braille New. And essentially what it does is it finds way to rearrange the typeface so that it can match the arrangements of the Braille. So that so we can simultaneously be able to experience both the visual, printed text, as well as the Braille version, which is tactile. Here, this is a second example of the security envelope, which I'm sure most people have seen in their life, but maybe just, you know, haven't thought about it way too much. Like I know I haven't. And so this is patterns, and there are multiple different kinds. Actually, there are names that get assigned to these patterns that are printed a lot of times on our bank envelope or insurance envelope or utility bill envelope as a way to protect sensitive information inside the envelope, right? So if one tries to use a scanner and try to you know, use different kind of technique to try to look through the envelope, it would be quite difficult because of the pattern that's overlaying on top of the letter itself. Here is another example also used during the wartime, and what this micro dot is this is a type of steganography. The definition of steganography is technique that hides information under plain sight, right? So in this case, what we're seeing is textual information, paragraphs, and written language shrunk to tiny, tiny little dots. It's so small that most people can't see it with their bare eyes, and you need a special tool and special microscope to be able to read the microdots. And these microdots during the wartime were embedded onto all kinds of objects, onto different parts of, you know, a document, so that to deliver message securely without being seen by people that's unintended. Here is another example of a kind of steganography, camouflage, which I think a lot of us are familiar with, and a technique that was really inspired from the animal world and the insect world, of like seeing how animal and insect have evolved to replicate or so imitate the environment around them. And that technique of camouflaging is then put towards use in the military. So when you see there are different variations of camouflage color, and that's supposed to correlate with different kind of terrain that the soldiers would be in, or different kind of seasons. So a lot of these kind of like visual steganography technique make great usages of patterns. This is another example called Razzle Dazzle. And this idea was actually created by a British marine painter, Norman Wilkinson. And essentially the idea was that maybe if we cover our military ships in these like dizzying strips of color, that it would be possible to warp the enemy's perception of the type and size of the vessels, as well as the speed it was traveling in and how far they were. So thinking about like visual tricks and visual perception is part of the prompt for this week, really in relation to loops. Here, another play and riff off of the Razzle Dazzle. This project originated by Adam Harvey in 2010 is called the CV Dazzle. And the CV Dazzle is a anti-facial recognition surveillance tool where Adam Harvey realized that by adding things onto the face, so that it would start not looking like a face to facial recognition algorithms, we can begin to hide ourselves and hide our identity in front of computer vision systems. On the left, the very left, you see the newest iteration that actually was just created this year by Martela Polinitz. And this example is teaching the protesters for BLM on how they might be able to use makeup as a tactic to create their own CV Dazzle when they go on the street to protest. And this is another example, really different kind of approach that actually borrow what we talked about last week, the Shanzai culture. So the idea of pirated fashion brands. In this case, it's pirating like Off-White and like the style of Supreme and these like kind of streetwear clothings that really use this kind of like white strips and like bold font as its signature marker. And the pirated version of Off-White, with a lot of times you see like, different kind of quotation or different kind of like randomly generated words when Off-White has been Shanzai'd. And so using this kind of cultural phenomenon of Shanzai, Amy Suo-Wu created this piece called the Thunderclap. And so what she did was pulling the quotations from the suppressed work of the Chinese anarcho-feminist He Yingzhen, who was alive from 1886 to 1920, and using her quote to fill in to the strips for the Off-White pirated clothings. And there's actually also another similar technique of embedding a QR code. So if you put a phone over the QR code, you can go read the original writing of the writer He Yingzhen. And so this is another interesting way to bypass censorship and bypass, like the authorities' ability to read what is being inscribed onto the body.
This is an example of a very interesting project. It's called 4QRXYZ, and it was created by by the artist Alexander Rabin. And so what happens here is this website 4QRXYZ encodes whatever code you put into it, and basically encodes that code into the browser URL. So what you can do is pack any kind of code, basically, that you can put in a web browser, from PHP to HTML, images, video, audio, or even plain text, and have it completely encoded in the single URL itself. What ends up happening is the page, the tool basically converts whatever you've input into base 64, and then attaches that to the end of the URL. And the decoding process reverses that, converting base 64 back to the original language before copying and pasting it back into the browser window. This project is fascinating because it does not rely on any server. The URL itself is the code repository. So, if you were to load this in, any format, basically, all the data that's needed to actually render the site itself is actually encoded into the direct link. It's a fascinating way to think about using certain technical elements of our browser windows and technical elements of the infrastructure of the internet, in order to be able to sort of bypass our assumed norms of how we navigate websites.
This is another example of thinking about steganography within the context of a browser. The project is called Decodelia, made by Melanie Hoff, and the project essentially is a Chrome browser extension that one can download. And once you download that, it would apply a kind of like red intricate pattern over every single website that you visit. And it's also going to turn the content of the website into a light cyan color. And if you have ever played this game, where you would, maybe get a ticket and it's covered in this like red pattern, and if you put a red filter over it or wear red glasses, it's going to reveal the secret message behind it. This worked the exact same way. So in order for you to be able to read what, you know, the content of the web, you will have to wear a red glasses. So the effect of this is when you are in public space browsing the web, no one else can look over and see what you are seeing, and the content between you and your computer in public space is totally privatized. And here is another project called Decoding Possibilities, using very similar technique as Decodelia, but totally different kinds of conceptual angle and context. So, so for this project, Romy Morrison, who created it, was really interested in thinking about autonomy within the Black community in the context of redlining and segregation. So oftentimes when we speak of redlining and when we think about the history of segregation, we often associate those keywords with Black poverty, Black pain, and Black death, and this way of creating a second layer or maybe a deeper layer of narrative is a effort to think about how those unfortunate history has also enabled different kinds of autonomy and different kind of solidarity among